Welcome to the amazing world of automobiles, where we explore the rich and sometimes quirky history of the machine that changed the world. In this program, we examine the past, present and future of safety, mankind's attempts to tame the beast we've created. Clever technology, new materials, methods and ideas all seek to protect us from the machine that changed the world, and from ourselves. Almost as soon as motor vehicles appeared on the roads, so did motor accidents, and that meant accident victims. Mass-produced cars streamed onto the roads, but driving skills and safety standards were uninvented. By the first quarter of the 20th century, Britain alone was counting its annual road fatalities in the thousands. An outraged public and a medical practice unused to seeing this level of human injury outside a war voiced concern, but both government and industry response was minimal.
In my opinion, the most effective safeguard against this appalling slaughter is a speed limit of 20 miles an hour in built-up areas and the institution of a higher limit on the open road.
Concerned mothers organized human barriers to protect children walking to school. No less an authority than Kenneth Soddy, author of countless books on mental health, wondered in the British Medical Journal if it would be possible to tame and domesticate this wild animal, meaning Foley, instead of building a cage strong enough to confine him forever.
Cyclists do not believe that cycle paths are a solution to the problem. In any case, they are far too costly to become general, and what we want is safety on every road.
Soon the police were given powers to enforce rules about road safety and were taking active steps to enforce it. Cars deemed unfit for use on a public highway were scrapped or destroyed. Of course, this was before recycling was common and before today's classic car collectors were born. Motoring enthusiasts were also keen to be seen as responsible advocates of safety.
When we walk, cycle, or motor, do we always remember to do the wise, safe, and courteous thing? Because if not, then in a flash, we may be the cause of throwing some home into despair.
Attempts were soon made to erect barriers to separate motor cars and pedestrians. Hay bales were used first, but weren't up to the weight of a car and flew apart. They went mouldy in bad weather, and the few remaining passing horses ate them. Over in America, a continuous steel rail on both sides of the road, mounted on stout posts, was tested the only way it could be, by having a real crash test dummy drive real cars into real barriers. The result was that even a solid-looking barrier would deform, and that absorbing the energy of a crash was best achieved with flexible steel railings. And despite what nearby Hollywood suggests, cars don't automatically explode when they go over a cliff, although this one may as well have. In the 1930s, American plastic surgeon Claire L. Straith and physician C.J. Strickland advocated the use of seat belts and padded dashboards. Strickland later founded the Automobile Safety League of America. Their research quickly showed that major injuries to car drivers were most often caused by hitting the solid steering wheel. At first, they encouraged engineers to build steering wheels that bent or folded in a crash. Removing sharp objects in the cabin and designing switches and levers that weren't a danger to occupants also became common, and the 1949 Tucker Torpedo became the first car with a padded dashboard. Later, manufacturers wary of spending money but keen to be supporting safety came around to the idea of restraining car occupants through the use of seatbelts. While the earliest seatbelts were devised in the 19th century, they weren't used in aircraft until the 1930s, and only in the 1950s did automotive seatbelts start to catch on. Seatbelt laws were last of all.
It's a technology that's reckoned to have saved more than 1 million lives, and I think it will continue to save 1 million more in the coming years. It still has a great potential, specifically looking at usage. So it's had a tremendous effect for sure.
Swede Niels Bolin invented a 3-point seatbelt for Volvo, first introduced in 1959. He realized that both the upper and lower parts of the body needed to be restrained during an impact such as a car crash. The greatest challenge was to create a simple and effective solution that people could fasten with one hand and that they would actually use.
At that time, many people were very scared, hesitating about how to be restrained the best way. So it was a very strong decision to implement this in cars.
Initial tests were done with live engineers, but pain thresholds and the need to examine the results of higher speed crashes soon sidelined volunteers. Some research really was done with human corpses donated to science.
Well, the seatbelt is the most important safety device fitted to any vehicle today. And since its inception, we've seen literally hundreds of thousands of lives saved with its fitment. And it really represented the very beginnings of modern vehicle safety.
Well, it saved literally thousands, probably hundreds of thousands of lives around the world. And what's been particularly important about it is it made it easier for people to protect them in cars by one motion they could buckle up. In the United States now we're seeing probably 15,000 people a year whose lives are saved just by the act of buckling up their safety belts.
In 1959, 3-point safety belts became standard equipment in Volvos sold in the Nordic countries.
To get the message through, to convey the world that this is actually something good, was something that took a lot of effort from Volvo and Niels Bolin. They did a world tour demonstrating it, they did stunts, they did all these tests, showed all this data, but it took a number of years before the general public and also the different governments around the world were persuaded that this is really a good technology, this is something that we should enforce, which happened during the 70s and 80s. So I think that's a recognition that the working process that Volvo established at that time, that's giving effect.
Bolin's invention was regarded as so important that the German Patent Office declared it to be one of just 8 patents that had had the greatest importance to mankind over a 100-year period from 1885. Few people will have saved as many people's lives as Niels Bolin. He himself died in 2002 at the age of 82.
25 years ago, the UK started mandatory belt laws whereby you had to use a seatbelt. It was required by the law. And since then, apparently 45,000 lives have been saved. And what we say in the UK is one life is saved every day by wearing a seatbelt.
Advanced seats, belt tensioners, airbags and neck restraints are useless if the vehicle occupant isn't first wearing their seatbelt. Seatbelts are also a key part of children's restraint systems, which have saved many youngsters' lives.
The next generation of safety belt will be improved safety belts. It will be the same principle, where you load the occupant in the most strong parts of the body. It will be more adapted to the size of the occupant and crash severity, and more user-friendly.
Well, the use can be improved. We still have a substantial portion of people in the U.S. who aren't buckling up, and as a result, we believe that if we could get everybody buckled up, we could save another 5,000 lives a year. It's 5,000 deaths that we could prevent if everybody would just buckle up. Now, what can we do to achieve that? One of the key things we can do, I think, is to have an effective reminder system in cars, where the car will electronically remind you if you haven't buckled up that safety belt by some noise that you would like to turn off. The other thing in the U.S. we need to do is we need some better laws. The way we've gotten most of our population to buckle up is through safety belt use laws.
If you look at a 3-point safety belt 50 years ago compared to a 3-point safety belt today, it's a huge difference. The basic principles are still there. You can put it on using one hand. It has a good geometry. It's holding the upper body, the lower body. But if you look at the specific technologies with pre-tensioners, load limiters, pre-prepared restraints, all of that, there's been a significant development of the safety belt and the restraint itself. And that era will continue. We've been looking at 4-point belts, etc. But whatever we will do, we'll still have those basic principles that were established by Niels Bohlin in 58-59.
An American inventor, John Wenrick, designed the original safety cushion for automotive use in 1952 at his kitchen table, but his patent lasted only 17 years. Dr. David Breed invented a key component, the ball-in-tube inertial sensor crash detector. Breed marketed this to Chrysler in 1967, and a similar crash restraint was soon offered by Ford. Airbags for passenger cars were introduced in the United States in the mid-1970s, when seatbelt usage was quite low. Ford built an experimental fleet of cars with airbags in 1971, followed by General Motors in '73. The experimental GM vehicles saw 7 fatalities, one believed to have been caused by the airbag itself.
The danger is to children, and especially to out-of-position children.
In the car?
In the car, yes. What happens? Let's take the out-of-position child, which is really not uncommon, and that's the child that's standing in the front seat with his arms resting on the instrument panel. In this case, his abdomen is exposed to the airbag. The airbag deploys or inflates, and the force is large enough to force him back into the seat, or in fact, perhaps even throw him back over the seat back. And this force is large enough in this particular system anyway, and I don't know about other systems, to cause internal injuries.
Now, these could be serious injuries.
These
Perhaps
could be
fatal.
very serious injuries, yes.
Could they be fatal?
It's possible.
Even for properly seated children, the front seat proved a bad place to be, as the airbags intended to cushion an adult's chest sometimes caught children under the chin, breaking their necks. In modern cars, electronic signals from various sensors in the vehicle are fed into a computer, which determines the angle of impact, the severity and force of the collision. In 1980, Germany got airbags first in the high-end new Mercedes-Benz S-Class, where sensors pre-tensioned the seatbelts to reduce occupants' motion on impact, then deployed the airbag. This integrated the seatbelts and airbags into a restraint system, and since then, more airbags have been added, sometimes as many as 10 in a single vehicle. Bags drop down from roof linings to protect heads or blossom from the sides of seats to protect hips, elbows or shoulders. Knees and feet have dedicated airbags, and vehicle and jacket-mounted airbags now exist for motorcyclists and even military helicopter crews. High-speed cameras and anatomically correct crash test dummies laden with sensors to measure G-forces and impacts help engineers design cars which withstand impacts with solid objects, poles and other cars better than their predecessors. In independently run tests, real cars are deliberately crashed under controlled conditions, and the slow-mo images are sobering for anyone who drives, is ever a passenger, or is a parent. Improvements in sensor and gas generator technology have seen the development of third-generation airbag systems that adjust their deployment to the size and weight of the seat's occupant. This reduces the risk of injury to small adults and children who were at increased risk of injury from earlier airbag systems. Many injuries result not from frontal impacts, but from the side. Vehicle occupants are just inches away from the outer edges of a car.
I built this car originally to show how well you could build a car for side impact.
Professor Hobbs, who was awarded the CBE in 2008, was key in setting up the European New Car Assessment Programme.
What we did was to make the sort of mistakes that everybody's still making. We made a very strong car. Unfortunately, when we tested it, we found a very strong car doesn't offer the sort of protection that we thought it would do.
Professor Hobbs, one of the British government's top safety experts, claimed that side impact bars, designed to absorb the force of an impact hitting the side of a vehicle in an accident, didn't work, In fact, he said they made injuries worse. In this test, a rigid door didn't absorb much energy. It transferred it to the occupants, whereas the softer door with an anti-penetration bar absorbed more of the collision's kinetic energy. One in 4 collisions in the UK involve side-on collisions. Crash tests now simulate both being hit by another vehicle and sliding into something rigid, like a pole.
I think there's a bit of a tendency for people to quickly get themselves some safety credentials. And one of the quick and easy ways to do that is to put beams in the doors, but that alone isn't enough.
Perhaps not surprisingly, car makers didn't welcome government interference in crash research and the imposition of the new side impact test. It's a moot point as to whether passenger protection would have advanced at the same rate if it were not for independent crash testing organisations like the European New Car Assessment Programme. By congratulating car makers that built safer cars, and by condemning those that didn't, crash testing has surely cost some manufacturers thousands of sales. A poor review here would be the death knell for a shaky product. The process has been embraced by the car-buying public, despite the fact that most drivers will never be involved in a crash this severe. Nonetheless, the speed of safety developments has accelerated in the past decade. Every year, tens of thousands of children are injured in traffic collisions simply because they don't have access to or use the correct safety equipment. Parents will be relieved to know that car makers take very seriously the safety of junior car occupants, and that junior crash test dummies are routinely included in laboratory crash tests. Because infants have heavy heads and weak necks, children under about 4 travel safest facing the rear of the vehicle, but their child seat must be correctly mounted and the seatbelt done up. Up to about the age of 6 and about 25 kilos in weight, the child should still face backwards, but if that's not possible, a booster seat should lift them up so the regular seatbelt can be used. A Europe-wide traffic safety directive requires that all children less than 135 centimetres tall must now sit belted into a child's car seat, something that will almost certainly reduce injuries. Child safety improves by as much as 5 times when children are correctly seated and restrained. The design of suitable seats for children gets more attention than seat design for adults because so much more depends upon it. Children's car seat design also presents more challenges as children grow at different rates, so age-based, height or weight-specific categories are not appropriate on their own. Children can also rapidly outgrow the expensive seats. Some car manufacturers have addressed this problem by engineering multi-adjustable rear seats that can accommodate children of different ages and heights. As a result, they're able to use the standard vehicle safety belt. This has the advantage of being designed in as part of the car's basic safety structure and not being a potentially inferior aftermarket addition. Because the vehicle's factory-fitted belts are attached to the car's designed-in safety features such as pre-tensioners and side and curtain airbag triggers, this design has found favour with parents around the world. Every driver knows that the brakes on their vehicle are the first, most important safety feature. Being able to stop reliably time after time or suddenly in an emergency is vital.
These 3 replacement brake pads are all intended to fit the same vehicle, but the brake pads can be made of different raw materials, and there's no way to tell how they perform by looking at them. So the consumer should look for a certification mark to ensure that the products he's putting on his car are intended to meet that vehicle's performance needs.
Knowing the basics of how a braking system works helps drivers understand how their vehicle functions.
When a person pushes the brake pedal down, they cause brake fluid to go through the master cylinder, through this brake hose to this brake caliper. The caliper pushes the brake pads tight against the brake rotor. causing the rotor to slow down, causing the wheel to slow down. Ultimately, then the vehicle comes to a stop. The brake system has to work together as a whole. It is a system. It's not just one piece.
Maintaining the brakes and periodically replacing some parts is a vital part of vehicle ownership. If just one vehicle can't stop in traffic like this, the results will be expensive and painful. Tests of new brakes try to replicate the worst possible situation for emergency stops. Here, 2 wheels are in the snow, 2 on the road, yet the car still stops in a straight line. Engineers are constantly working towards better results. New designs and materials such as carbon fiber and ceramics improve durability and reduce stopping distances. About 3/4 of reported collisions occur at speeds below 30 km an hour, and mostly in dense traffic. With modern cars, injuries are seldom severe, but the disruption to traffic and cost to motorists and their insurance companies are large. Volvo have developed a system that assists with braking if it decides the car is about to collide and the driver doesn't react. The car literally brakes by itself.
The system works that we have a optical sensor placed in the top of the windshield, which monitors the traffic in front of the vehicle. And when we see a hazardous situation close to collision, we intervene with the brakes and avoid the collision.
The optical radar system can detect cars that are quite far ahead and can assist in braking at speeds below 30 km an hour.
The uniqueness in this system lies in us preventing the accident instead of dealing with the consequences of it.
City safety is the kind of technology we'd like to see in all new cars, but it may take a few years to become universal.
The ambitions with the system is, of course, to drastically lower these type of city traffic queue collisions. And our ambition is actually 50% reduction.
A reduction in collisions would lower repair costs, which should lower insurance costs too.
Of course it will minimize the collisions, but it's actually the risk for whiplash injuries in these type of collisions and the very large insurance costs that are involved in these type of collisions that is the real point.
Whiplash injuries are one of the most common injuries in low-speed collisions, but their effects can last a lifetime.
In Sweden we have had a fairly long tradition of research into the field of whiplash. We have accepted whiplash as a major problem in traffic. So we have done epidemiological studies seeing what is the frequency of this injury. And from that we have also seen that car manufacturers have started to look at solutions to protect from whiplash. We have also in Sweden developed the research and development tools needed in form of a good crash test dummy developed especially for whiplash protection assessment.
Road authorities and engineers from car makers accept that in the future, systems like CitySafe will avoid many small collisions. But before the system can be signed off for production, it needs to be thoroughly tested. Perhaps more fundamental than good brakes and clever crash-avoiding systems are good tyres, the 4 points at which every car touches the ground. Far from merely being black rubber hoops filled with air, a modern tyre is every bit as sophisticated as the car to which it's fitted. The average tyre has over 300 chemicals in the mix that's formed into the shape we know and recognise as a common tyre. Embedded high-tensile steel wire keeps it on the wheel, while the carcass, the shell onto which all the other parts are fitted, is a super-strong woven mesh. Tyres need to perform at high and low speeds, at high and low temperatures, baking heat, sleeting snow and driving rain. They need to grip the road going forwards and backwards during braking and accelerating and withstand sideways loads when cornering. They need to offer predictable grip on tarmac, concrete, bricks, cobblestone and loose gravel, sand and mud, and displace up to 5 litres of standing rainwater per second. Engineers continue to work on new rubber compounds, new tread designs and more efficient, longer-lasting tyres. But the development continues, and now many vehicles are fitted with tyres that can be driven on at reduced speeds while they're flat. This means carrying a bulky spare wheel and the tools to change it is no longer necessary, a bonus for car designers chasing every cubic centimetre of usable space and trying to cut out every unneeded kilogram and dollar from their production vehicles. Other developments include sensors embedded inside tyres to measure pressure, temperature and contact patch. This data is sent to the car's computer, which can change the suspension settings and drive characteristics to equalise load and ensure all the tyres are being worked evenly. This means a smoother, safer ride for occupants and a longer lifespan for the tyres. As cars improve, it's vital that their tyres do too. The trend has been to wider tyres, giving more surface area for better grip. But wider tyres mean more chance of the tyre floating or losing grip, aquaplaning, on a wet surface. If the tyre's not touching the ground, it cannot steer or slow the vehicle. So tyre engineers use special wet weather tracks to replicate intense downpours on a variety of road surfaces. With its driver aids turned on, this BMW would never spin like this. Car and tyre makers have reduced the risk of a rollover, and out-of-control cars are more likely to spin or slide and lose speed very rapidly. Just another way the evolution of cars is making them safer and safer, even when things go wrong. The suspension of a car, the system that absorbs the bumps and keeps the car level, is another area where talented engineers are seeking solutions to problems most of us don't even know exist. Clever computer programs allow engineers to design parts on screen and marry them up with other parts to make sure they all fit together. And then they can test the new car to a certain extent, long before a single piece of metal is cut, bent or welded. And three-dimensional models can be quickly made in plastic if something needs to be examined by hand. Once the newly designed parts have been physically made, suspension systems are tested on computerized test beds that can be programmed to simulate the harshest conditions on the planet, from ultimate high-speed laps on demanding racetracks to incessant pounding on the worst roads in the world. These test rigs can run 24/7, and often tests are run until destruction. Eventually, something fails, and it's up to the engineers to improve the design until they achieve a happy blend of longevity, durability, and price. For everything in a car has a price. Once the major points are established, it's down to fine-tuning the parts which actually do the work, and no amount of computer simulation can quite match testing under actual road conditions. The trouble is, the car for which these new components doesn't yet exist. So engineers use strange-looking cars like this one, which are almost infinitely variable and never intended to be driven on public roads. Weight can be added or subtracted, moved higher or lower, further in or out, forward or back, to replicate the basic dimensions of the as-yet non-existent car. These so-called mules carry sensors to measure almost everything that can be measured, and banks of computers to record all this data. And often, this is fed back in real time to engineers in design offices tens, hundreds, or even thousands of kilometers away. Using mules, engineers can measure the real-world effects of different spring rates, different dampers and bushings, all the unseen variables that make a small but tangible difference to what drivers will experience when they get behind the wheel of their shiny new cars many months in the future. But the testing doesn't stop with the mules. Once the first few cars have been built, usually by hand, more testing validates the early work. Now it's about making final decisions about the very small details and making sure that the tyres fitted to the car when they roll out the showroom door are appropriate to the country and the climate in which they're sold. Sometimes tyre manufacturers will modify a range of tyres to suit just one particular model of a car. Here's a graphic illustration of what can go wrong when a driver loses control swerving around an obstacle. The difference is that in the second example, the car is equipped with a variation of electronic stability control, ESC for short, just one of several computer-controlled driver aids that can step in and help the driver stay in control. Most ESC systems work with the anti-lock brakes. An onboard computer reads the speed of each wheel, the angle of the steering in relation to where the car's going, and what's happening with the throttle and the brakes. In a split second, the car decides whether it's going in the direction that the steering is pointed, and if not, it'll apply short bursts of braking to one or more wheels to slow the vehicle and bring it back to where the steering is pointed. In the case of the black SUV, the situation of the rear coming around and turning the vehicle further around them was required is called oversteer. In the silver Chrysler, the car fails to steer through the corner and runs wide in a situation known as understeer. Here, on a wide and empty test track, there's no harm done, but on a busy road with other traffic and vehicles going the other way, either incident could have catastrophic effects. In most cars, the ESC is switchable. There are some circumstances where a good driver doesn't want the system interfering, in mud or snow, for example. But with ESC engaged, the big Chrysler gets through the artificial corner with ease. With a small hatchback on a dry track, the action of the ESC system is even more noticeable. Some ESC systems will also reduce engine power until control is regained. Electronic stability control doesn't improve a vehicle's cornering performance. Rather, it helps minimize a loss of control.
ESC, electronic stability control, goes by various different names from different manufacturers, such as VSC, ESC, ESP, for example, but fundamentally they all do the same thing. They stop your vehicle getting into a spin, a skid, a serious condition where your vehicle might leave the road and there could be a potential fatality.
In the United States, it's estimated that almost 10,000 fatalities could be avoided if all passenger vehicles were equipped with the feature. According to the Insurance Institute, 1/3 of fatal accidents could be prevented by the technology.
ESC works by preventing your vehicle getting into a dangerous situation, such as a skid or a spin, that could therefore involve your vehicle going off the road and being involved in a potential accident. And it does this by selectively braking individual vehicle wheels automatically without the driver's intervention, and thus it prevents a crash happening in the first place. So this technology avoids a crash. Unlike a seatbelt or an airbag, this technology can avoid a crash happening in the first place.
And while the feeling of the brakes being applied, sometimes quite forcefully, can be alarming to the driver, it's a lot better than the alternative.
What we're trying to do today is to raise the awareness of ESC, get people to buy a vehicle with ESC, get people to specify it as an option and specify that option before they consider fancy alloy wheels and metallic paint, because ESC, literally 3 letters that can save your life.
The Australian state of Victoria, the first place in the world to make the wearing of seat belts compulsory, will insist that all new cars sold after 2011 have a variation of ESC. We've already seen how crash tests are performed and how parts can be designed and tested on screen. Massive computing power and computer-aided design software mean that whole cars can be designed on screen and crash tested there too. While this process doesn't yet replace the validation of crashing real cars in the laboratory, many valuable lessons are learned and millions of dollars and thousands of hours are saved by using the power of computers. New ideas can be tried and either discarded or taken on for further evaluation. Started in the late 1980s, the development of readily affordable computer-aided design programs that could be run on personal computers began a trend of massive downsizing in drafting departments in many companies. As a general rule, one CAD operator could readily replace at least 3 to 5 draftspeople. Hard on the heels of CAD came computer-aided engineering and manufacturing, wherein entire designs were fed to computer-directed milling machines and lathes that produced components automatically, identically, and working, if necessary, 24 hours a day. Advances in virtual reality software have also meant that, instead of looking at the components on a flat screen, engineers can enter a three-dimensional virtual reality car and see how parts come together in life-size or larger if need be. Crash test dummies are full-scale test devices that simulate the dimensions, weight and articulation of the human body. Modern dummies are complex and expensive machines, able to record data about simulated vehicle impacts, such as the velocity of impact, crushing force, bending, folding and deceleration rates during a collision. Now this is where they go to work, vehicle crash labs around the world. The first test subjects were human cadavers, dead bodies. They were used to get basic information about the human body's ability to withstand the forces experienced in a high-speed crash. Cadavers fitted with crude accelerometers were strapped into cars and subjected to head-on collisions and vehicle rollovers. Researchers now suggest that as a result of design changes in cars up to 1987, cadaver research saved 8,500 lives annually in the US alone. However, work with cadavers had many problems. Not only were the moral and ethical issues, but as the majority of cadavers available were older European American adults who died non-violent deaths, they didn't represent a cross-section of car crash victims. Some researchers used themselves as crash test dummies. Professor Lawrence Patrick took over 400 rides on a rocket sled to test the effect of harsh deceleration, and his students allowed themselves to be smashed in the chest with heavy pendulums, hit in the face with hammers, and sprayed with shattered glass to imitate window implosions. In 1949, a dummy called Sierra Sam was created to test aircraft ejection seats and high acceleration to 1,000 kilometers an hour, beyond the capacity of humans. In the early 1950s, a dummy was used to conduct crash tests in cars. Crabby is a child dummy used to test child restraints, including seatbelts and airbags. There are 3 models, an 18-month-old, a 12-month-old, and a 6-month-old infant. Thor is an advanced male dummy and has a human-like spine and pelvis. Its face contains sensors, which allows analysis of facial impacts. A problem with dummies is that they are only ever approximately human. 44 data channels isn't even close to what a living human experiences, and so far the mimicking of internal organs is crude. Almost 2/3 of the 1.2 million people killed worldwide in road crashes annually are pedestrians. But crash engineers are now using design principles that protect car occupants to develop vehicles that reduce injuries to pedestrians. Redesigning the bumper, bonnet and the windscreen without compromising the structural strength of the car and causing the bonnet to pop open all help. Most pedestrian deaths are caused by brain injuries when the head hits the bonnet or the windscreen. The bonnet of most cars is flexible sheet metal, which is energy absorbing and poses a minor threat. A 10-centimeter gap is enough to reduce the risk. But creating room under the bonnet isn't easy because of aerodynamics, packaging and styling, so designers have used deformable mounts and more ambitious answers such as airbags or pop-up bonnets which add 12 centimeters extra clearance over the engine. Of course, the easiest way to avoid hitting a pedestrian, especially at night, is by being aware that they're there. Thanks to technology that uses infrared cameras and advanced onboard software to recognize humans, several cars are able to warn of pedestrians, as opposed to other hazards beyond the range of even the best headlamps. In 2000, General Motors introduced night vision on the Cadillac DeVille, which became the first vehicle sold with such a system. Since then, Toyota, Honda, Mercedes, BMW and Audi have all offered it in their high-end models. Another, perhaps less expensive way of detecting unseen hazards is to equip cars with equipment that detects an electronic signal from low-energy transponders in commonly carried devices like mobile phones or even key fobs.
The transponder uses 2 different types of technology. It uses wireless communications to send and receive wireless signals to other devices or other users. It uses GPS to receive its location information that it can send out to the other users and receive location information from the other devices.
Technology that used to fill the boot now fits in the palm of your hand. Tiny transponders can be detected at enough range for the vehicle to alert its driver to the presence of, and possible risk posed by, a pedestrian, cyclist or child.
Now we can begin, since this is miniaturized, imagine being able to retrofit all of the cars on the road with this kind of technology. This is a huge breakthrough, and because it's become much smaller, it's going to be much more affordable to do.
The technology is called P2V, or pedestrian-to-vehicle communication.
Cyclist ahead.
Car makers hope that this technology will one day be standard equipment in all the small devices that people might carry: phones, iPods and keys. Driver drowsiness detection is a car safety technology that prevents accidents when the driver is getting sleepy. Current systems learn driver patterns and can detect when a driver is becoming drowsy. Drowsy driving, that's sleep-related vehicle collisions, are a common type of road crash involving single or multiple vehicles. Several systems to counteract driver drowsiness exist. Driver Alert works with lane departure warning to alert tired and unfocused drivers if the car crosses one of the road markings without an obvious reason.
Driver Alert Control is a system that analyzes the driving behavior of the driver, and if it detects that the driver is unconcentrated or tired, it alerts the driver.
Other systems use infrared sensors to monitor driver attentiveness. A camera on the steering column tracks the blink rate of the driver's eyes. When tired, humans blink more slowly and less often.
We think it's great that automakers are putting this kind of technology into vehicles. You know, we're seeing things like drowsy driver alert. We're looking at efforts to mitigate the collisions, that is, apply the brakes before they happen. This is very good technology, we hope. Ultimately, we'll be doing research on it to see just how well it works in real crashes.
The Mercedes Attention Assist gives a visual and audible alarm to alert the driver if they're too drowsy to continue safely.
I think as a complement to crash prevention or crash injury prevention, which industry has worked with for many, many years, to complement that with the accident reduction in those modern systems is a very positive trend that we see.
Toyota's driver attention monitor system will warn the driver with flashing lights and warning sounds. If no action is taken, the vehicle will apply the brakes briefly.
We've been driving with a lot of different test subjects, both on test tracks and on public roads, just to see that the system can detect that the driver might be unconcentrated or tired, and also that it doesn't give any false warnings.
Another option is a pair of glasses that measure eye blinks and communicates with the car and sounds an alarm if the driver shows signs of drowsiness. This is an area of evolving research by sleep scientists around the world. 1 in every 3 traffic fatalities in Europe is alcohol-related. To help reduce this number, Volvo has developed AlcoGuard, which uses fuel cell technology to accurately read a person's blood alcohol level. In order to start a vehicle, the driver must blow into a wireless handheld unit. If blood alcohol level is higher than the legal limit, the car won't start. It's hoped this technology will lead to a change in the general attitude towards drinking and driving, resulting in the elimination of alcohol-related accidents and deaths.
When you go into the car, it asks you to take a test. So you blow into the unit and the result is analyzed. And if you don't have any alcohol in your blood, you're able to start the car. And if you have a red result with alcohol, you're not able to start it.
If one of the LEDs on the device is red, the car won't start.
Accident statistics show that drunk driving is a major challenge in road safety, and for Volvo it is a natural step to develop a user-friendly alcohol interlock so that we can contribute to increased road safety.
The percentage of alcohol allowed in a driver's blood varies from 0 in places like Brazil to 0.02 in Sweden and China, 0.03 in Russia, 0.05 in most countries, and 0.08 across North America and the UK.
Even though people seem to be against drinking and driving, many people still do. And I think the reason people still drink and drive is because they can get away with it. There just aren't enough police officers to catch every drink driver. And they know that they could probably drive every weekend for more than a year without being caught.
At present, use of the system is voluntary, unlike alco locks, which can be imposed on drink driving offenders by the courts.
We think it's very important in the US as well to explore the kind of technology we can put into vehicles that will prevent people from driving when they're drunk. The fact is we still lose an awful lot of people in motor vehicle crashes from alcohol-impaired driving. And we estimate that if we could just keep the amount of alcohol people are drinking below the legal limit in the US, 0.08, we could literally save more than 8,000 lives each year. This is a tremendous advantage.
Many countries have reduced or zero limits for new and young drivers. Amazingly, people in the US and UK can legally fly aircraft with a blood alcohol limit that would see them illegal to drive in countries like Estonia, Poland and Puerto Rico.
The only way to eliminate drunk driving is if vehicles have technology that can measure if you have alcohol in your blood, how much, and if you're over the limit, not allow you to start your vehicle. And I think that obviously vehicle manufacturers are very important in this effort.
And that would certainly make policing a lot simpler. And finally, a different take on the meaning of road safety. While a century ago a motor car might have just scared the horses, nowadays car makers have realized that they can make serious money out of the uncertain times in which we live. This may look like an ordinary Jaguar, but appearances can be deceptive. This Jaguar XJ long wheelbase has been modified to protect its occupants against firearms, blast attack, robbery, kidnap and carjacking. So, what has made some of the world's most prestigious luxury car makers decide to make armoured vehicles?
During the course of the last 2 years, the global political situation has changed dramatically. Incidents of suicide bombing, aggressive attacks has increased in the global stage, and with the growth in that situation, we decided to move into formally armouring vehicles as Jaguar to give a fully warranted, fully serviced Jaguar armoured vehicle.
Many manufacturers are cashing in on consumers' security fears and now making cars with added protection.
Jaguar's armoured car is joining a growing band of manufacturers, if you like, who are offering armoured protection for their customers. In some ways you can look at it as the ultimate executive toy, on the basis that it offers you something that none of your colleagues or indeed rivals would have. And on the other hand, there's a serious side where it does offer protection and security for important people who work in the public eye.
The fully warranted armoured Jag can also be fitted with run-flat tyres, tamper-proof exhausts and self-sealing fuel tanks.
The car will be assessed and tested to a fairly serious degree for it to be sold as an armoured car. I mean, it's not a toy, if you like, even though it may be bought by people who want it purely for novelty value.
BMW regularly show their latest security models to discreetly interested clients at international motor shows.
So the passenger cell is protected, and mainly to give protection to the occupants, you know. So it's no need to protect the engine compartment, it's no need to protect the luggage compartment. So we focus on the passenger cell and gives protection up to the level before. It means against street criminality. It means as well 9mm pistols, 357 Magnums and 44 Magnums with the maximum speed possible. And this is tested and certified by independent German authority, state-owned authority, and we get after the shooting a certification to prove to the customer that the car gives protection.
In fact, most luxury manufacturers will admit to building armoured vehicles for the wealthy, the vulnerable and the paranoid. It's a small but important market niche. The Jaguar has added armour plating and protection to the car's engine. The vehicle's suspension and braking systems then needed to be modified and upgraded to carry the extra weight, but you'd be hard-pushed to see that at first glance. The car has been intentionally made to look as innocuous as possible. If you think there's someone out to get you, for about £200,000 sterling, this Jaguar could be the car for you. Should an assailant's bullet hit the tyres, the car can still travel for 50 kilometres at speeds of up to 80 kilometres an hour. In the development process, every aspect of this car's armoured protection was shot at, blown up and tested by leading independent auto ballistics and blast testing specialists.
What you're trying to do with a ballistically protected vehicle is buy time. So what we're looking to buy between 10 and 15 seconds of time to protect the key individual in the vehicle. The idea being is you come under attack and you escape from the situation as quickly as possible.
So everything looks to be in place for the cash-rich driver who may need to get out of trouble in a hurry.